Say that we want to cut a hole in this Hypar mesh. I've drawn in the hole, the kind of position of the hole just here as a circle. If we look at this in 3D, we can see the circle and the Hypar mesh. And we might want to cut this hole to let a pole go through for another shade structure, or perhaps to have a corner of a shade poking through that hole. And as long as the hole is relatively small compared to the whole mesh, then all that we have to do is we can assume that the mesh, that is the shade sail, takes the same shape that it would take if the hole wasn't there, and just project this circle onto the mesh as a shape that we can cut out to obtain the circle in the production version. With MPanel we can carry detail through to the paneling using points, panel detail from points, and so our job becomes to project this circle down onto the mesh, convert the projected circle into points, and then MPanel can carry it through on the paneling. The process of doing this is straightforward, but it's a little bit counterintuitive. To project the circle down onto the mesh, we would use a cross-section, and we would specify that the cross-section occurs using a 3D poly as a cut line. By using a 3D poly as a cut line, instead of using a straight line as a cut line, we can use any shape that we like. So our first job is to convert this circle into a 3D poly, and we'll do that with the Convert to 3D Poly tool. So now we have a 3D polyline which is in the shape of that circle, and of course it is still in the same position, not in the mesh surface that we had before. We would then run the cross-section tool with the mesh and the 3D poly, making sure that we've got two settings made. One is to allow or use a 3D poly as a cut line. The second is that I'm going to specify the number of points in the cut line as 0. This is just going to let me optimize the shape more later by stopping the renumbering process in the cross-section tool. So we'll go ahead and run that tool. I'll get rid of the circle so that we can see things more clearly, or the 3D poly that is representing the circle, and we can see that we have a cross-section. This lays in the plane of the mesh, and because we've specified 0 as the number of points, that is no renumbering of the points, we have 1 point exactly at each point that the circular polyline before crossed one of the mesh threads. We have a little bit of an annoyance in that we have a gap here where there weren't any mesh threads, and I'm just going to draw in a polyline across there to close that gap, and I'm going to join those two polylines together using the tool Join Polys, and that gets rid of the gap, which is rather annoying. Now this obviously is a fairly rough representation of a curve, because it's only picked up these specific points where the original curve crossed the mesh threads, and we can make it smoother by fitting a spline to that using the poly to spline command. Again, I'll delete the old object, and we'll now find that we have a spline representing the shape that the circle would take when it's projected onto that mesh. So now we've got a curve shape, a spline, in the surface of the mesh. MPanel needs points to carry through as detail, and so we'll use the AutoCAD command here to draw points. We'll use the divide and say that this object here needs to be put into about 100 points. I should be able to delete the spline now, and we can see the points drawn out. Your point display may be different depending on how your AutoCAD is set up, but the points are still just the points. We're now in a position where we can go ahead and panel this. I'll set this to panel into 3 panels. I perhaps have one other thing to do. It's useful to join the points together in the panel, and in MPanel we join colored points together. So I'm going to just go ahead and color those points. Any simple primary color will do. I'll use yellow here. Now we can select the mesh and the points and just panel conventionally. And if I pick up one of these panels and move it off to the side to where we can look at it, you can see that we have the panel and detail drawn showing the shape of the cutout that's required, and of course some of the detail for the cutout is on the next panel. Often this detail would be plotted out on the panel and might be cut out by hand, even when the rest of the panel is cut out automatically. And that's probably quite adequate for any situation where the hole in the shade sail is small enough to where the shape of the shade sail is not appreciably altered by the hole. If the hole is sufficiently large to where the shape of the shade sail is going to be altered by the hole, then we have to model the hole in 3D, and that'll be the subject of another video.